All right, we're going to get started and call the meeting to order at 4 o'clock. Roll call, at-large Cummins.
Here.
At-large Poshton.
Here.
Ward 1 Walker.
Present.
Ward 2 Helm.
Here.
Ward 3 Johnston.
Here.
Pledge of allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, next is approval of the agenda. Any questions, concerns, amendments, or changes to the agenda?
Motion to approve.
Okay, motion to approve by Cummins, seconded by Johnston.
Poshton,
Yes.
Welker,
Yes.
Helm,
Yes.
Johnston,
Yes.
Cummins.
Yes.
All right, next is communications portions. There are no scheduled communications. Is there anybody present that would like to address the council not concerning the solar project? No. Okay. All right, we'll move on to city business. There's only one item, and that's discussion of possible action concerning the solar array presentation by Custom Builders and Tri-City Electric, the selection of a company to construct the solar array, and authorizing the city attorney and city staff to finalize a Tipton solar array agreement. I think, go ahead. Did you want to say anything?
Well, it's set up so that you can make a final decision tonight, just like it's worded. That isn't necessarily so if you're not ready. If you want to take some time to think about it and bring it back to your council meeting that's coming up on Monday, that would be an option as well. And I believe Tri-City Electric has volunteered to be first. Both sides have, I believe, agreed to not attend the other's presentation.
And both of them have presentations, so council members may want to reposition. Yep, reposition. So Custom Builders, if you want to hang out in the hall or outside, we'll come out and get you when Tri-City is finished. Yeah.
I'll move your seat so I can get by my teeth.
Excuse me. Sure. On the day, Luke.
Oh, you better sit next to me.
Oh my God.
I'm watching to
Are you
make
kidding
sure
me?
you don't fall like you can't get off.
Seriously?
Seriously?
Oh, she's cheerful. I'll keep you all the look back.
We're not gonna see your look because we're going that way.
I was back ahead of you. Do it. We're back. I can do later.
Good.
Yeah, go ahead whenever you're ready.
All right. Thank you, everyone, for being here tonight. On behalf of TJ and I, we're super excited to be here tonight and excited for the city of Tipton to be looking at this project. My name's Andrew Palmer. I'm the renewable energy manager at Tri-City Electric. I just wanted to start off by giving you a little history on Tri-City if you're not aware of who we are. We are a family-owned company. We just turned 130 years old in March. We started in 1895 as an electrical contractor. Over those 130 years, we've grown our services. We are now doing low voltage technology systems, renewable energy, structural steel, power testing systems, millwright services, and fire protection. We just added 3 more companies to our company here in the last, since December, which is Triber Construction, B&B Masonry, and Industrial Steel Erectors. We've worked in 46 states, 2 U.S. territories, and 6 different countries. I don't say that because we chase work across the globe. Our customers here locally in Eastern Iowa and Western Illinois have confidence in Tri-City for us to get the job done right and have confidence to take us across the country and the world. So I'm going to turn it over to TJ, and he's going to talk about the specifics of the project and our other capabilities.
If I stand here, I got a few notes on the podium, but yeah. So that's just a little bit about Tri-City, but our experience. And so the Tri-City Electric, the Renewable Energy Division, which is the division we're a part of, we've constructed successfully and safely over 35 megawatts of solar in the Midwest. And that is no small task, but what comes down to the difference between us is, who's on our team. That's all we do. That's all we do is solar energy, renewable energy. Andrew Palmer is the division manager. He has managed successfully those 35 megawatts of solar energy. Brian, a project manager with us. He's a master electrician with over 20 years of experience in electrical industry. Myself, I'm involved in project development, business development, and I am a certified NAPCEP PV installation professional through the NAPCEP board. Then we have Sam, who is a project engineer, and he is certified NAPCEP PV commissioning and maintenance specialist. That is his expertise in the NAPCEP certification. And then we also have Crystal Miller, which she does a lot of our quality assurance, quality control, and she heads up our operations and maintenance team. So we have a team dedicated to just servicing solar arrays across the Midwest. And her team, that's all they do. And I know with the city, one thing they want to know is if something happens, is it going to be taken care of? We have a division within our division, our renewable division, we have a service team. That's all they do is they service equipment, not just that we've installed, but other people have installed across the Midwest. To give you an example of some projects we've just done and completing the recent year and a half, these similar projects are similar to what would go in at Tipton, 1.29 megawatt, 637 kW, 2.86 megawatt, 1.29. These are all in Iowa. A couple larger systems, a 3 megawatt, 5.1 megawatt, 5.02 megawatt systems. Those are in Illinois. And then the corner there, that is actually our headquarters in Davenport. So we just don't install it. We actually have it on our headquarters facility. It's been up and running, what now, 7 years now?
7 years.
7 years. Good. And so with our proposal, we knew the limitation was the AC value of the system to stay, that doesn't go over a megawatt. So we're looking at what can we do, and our aim was to be the best value at that size system. So quality equipment was number one, optimal design for production and longevity. So we took a holistic approach is what can we do to make sure we can maximize with the limitations we have on the AC value, what can produce the most power at the best bang for the buck. Number three, our excellence in workmanship. And then number four, the best balance between system cost and cash flow initially and long-term. And so there you see the system that we designed and came up with, the system size, about 1.122 megawatt DC, 1 megawatt AC. Estimated production year one, 1,638,682 kilowatt hours. And our installed costs, just a tick over 1.5 million. And then I add an extra category because you can pay for a system, which the system is what's installed. Really what's important is the production. What does it produce? So cost per megawatt hour. So about $925 per megawatt hour is what that system produces. You notice that is a bit higher than the original proposal we gave because that is what's coming with tariffs, equipment costs. They're on the rise. They're coming. We know reciprocal tariffs are going to come within 90 days. They're going to be hitting and the whole solar market is going to be impacted. And so we know if the council is interested in going with the project, the sooner the better in terms of saving the most on the system because it's just going to go up. We have value engineered the system as best as we know how to, but we can't control what the system components cost. So that is, they cost what they cost. So the equipment we determined to use, the solar module and the inverters I have up here. The solar module was selected for many reasons. One is in the basis of design, it was said to be a ZN Shine module or equivalent is being spec'd in. And so we went with that same manufacturer knowing it's an approved manufacturer already. but we went with their N-type TopCon bifacial module. Bifacial means it's going to collect sun energy from the underside, so it's able to harvest energy from the underside of the panel, which our projections are only projecting what the top side is going to gather. But also their N-type module is going to have a slower degradation rate. So all modules degrade over time. The TopCon technology is going to degrade much slower than a PERC or similar technology. So it's 0.4% degradation annually. Every module degrades the most at the first year. This is only 1%, then every year after that, 0.4%. It's got a 30-year output guarantee, so that it's hard to see it on there, but at year 30, it's still guaranteed from the manufacturer, putting out over 87% nameplate power. The inverters are a Solus inverter, and we selected this one because it's got a great warranty, can be extended up to 25 years, but also its efficiency. It is a very efficient inverter, and for the size of this inverter, not many inverters have multiple MPPTs. I don't want to get too crazy with what an MPPT is, but if you can click again, an MPPT is really what's called a maximum power point tracker. And what that's doing is it's dealing with the voltage and the amperage in the technology is seeing what is the best power output that string of modules can put out. And so that technology is always tracking, when the sun's shining and when all the things are taking place, what is the best power that string can produce. And so the more MPPTs means the greater output, potential output for that system, because each MPPT is isolated on its own. And the next picture here will show you what I mean. So here's one row in our design. There's one inverter for each row. So these are string inverters, and what that means is you can see there are strings of anywhere from 15 to 17 modules that are connected together, and then it makes a loop to the inverter. And so that is its own circuit. Well, that means those 15 to 17 modules are working as a unit. They work together. If one module is impacted, it affects the whole string is impacted. Now with MPPTs, you tie in each string into the MPPTs. And so some inverters like this size might only have one MPPT. So that means that entire row is actually one unit. One panel affects the entire row. The more MPPTs, it isolates each unit, and these inverters have up to 10. And so per row, there's about 12 strings. That means each one of those strings will have just one MPPT and possibly two strings on one other MPPT. And so I show that because this is going to, over time, the most power production that can be produced with this string inverter. Both of these equipments, so the inverters and the modules are Bloomberg list tier 1. To be on that list, it has to be a bankable, trustworthy manufacturer, and they continue to be on the list even in this quarter this year.
Where are they manufactured?
The modules all over, typically a lot of them are coming from Indonesia. And the Solus inverters are also manufactured. They're both Chinese companies. I'm not going to hide that, but they're manufactured in different areas all across the world. So our design, so it's going to have modules, racking, inverters, all the AC gear, which is typical of solar, but this is everything else that our proposal includes. So we're going to have site grading to achieve a maximum of 4-degree slope from west to east and north to south, and that is per manufacturer requirement. They're not going to allow a tolerance more than 5 degrees when you're putting that racking in for their warranties. But that's also going to minimize shading. That land out there, the terrain dips down to the north. Those modules and those rows, if you didn't do any grading, those will be shaded. They're going to be shaded, especially during wintertime, they're going to be shaded. And so this is to minimize shading and then create a positive drainage as well. It includes access road we're going to build with everything that's required for an access road, drainage, culvert, backfill, geogrid, all those things. This includes SWIP permitting, erosion control, site stabilization. Before we get out there and start doing anything, we're gonna build a silt fence around the perimeter, and that's gonna stabilize it. And so we're gonna keep that out until it is achieved, that stabilization. If there's any mowing or vegetation control while it's being constructed, we're gonna take care of that as well. We do have a 6-foot galvanized chain link fence to match the existing fence that's around right now the water treatment plant. So it's gonna be the same exact fence. And we also have, it doesn't say it here, we'll have 2 entrances. One is a drive-in entrance with a double gate, and one the opposite of the race, so it can be accessed with the man gate. So you can access it both sides. We're gonna walk all the way around. Finished seeding and covered within the fence area, and that's gonna be a native pollinator seed mix. It's a wildflower seed mix. We can share what that exact mix is. That's got various perennials and things like that, and hydro mulch cover that will go in with that. One thing we're also going to do, all conductors will be in conduit. PV wire is rated for direct bury. Doesn't mean you should do that. I have personally had to trench in new PV wire because an animal bit it and it had to be redug and put back in. So everything will be in conduit, no direct bury. Ours includes a cellular kit. I know there was a microwave system that could be used for monitoring. We're actually going to do a cell kit so that this system is able to function on its own with the cellular kit to monitor the system, and that has a 10-year cell plan that comes with that. Another thing we're going to do is we're going to add an additional Ethernet line from the lead inverter, which is like the master inverter that everything else is communicating to where the PV disconnected AC combiner is by the transformer. And that's is ever you want to have Ethernet connection to DAS system. That way, you want to do more controls, more things like that, it's already going to be in the ground. You're not digging anything in later after the fact. We're going to commission the system. We're going to set up the monitoring portal. We're going to train you on how to use it, how to start it up, what the monitoring portal does, all the different functions you can see, and how it is producing. So here is our grading schedule. I know the numbers are hard to see, but it's going to go down roughly a foot about every 20 feet. This is the grading schedule will be. And this will be done in-house by our very own Triber Construction. So they're going to take care of that. That's what they're capable of doing. So that will be in-house to do that as well. And here is the preliminary design of our array. You can see each inverter per row. And then just down when you get to the smaller ones, it's just going to be the only PV wire that'll actually be in the ground. That's from that far row at the bottom going to that inverter in the next row. All the other PV wire will be directly under the modules for ease to get to it. If anything happens, all the PV wire is underneath the modules. Schedule. Here is our estimated schedule, assuming the project is contracted in 7 days. That's what we base that off of. It would have us completing the project by that October 31st deadline that was in the RFP. And if you notice, it says like 6/12 is when we would actually get on site and start building. Construction would end about the middle of September. So roughly 3.5 months of build schedule, which is under that 120-day limit that the RFP wanted to be under for construction. Next thing we want to look at is our excellence in our workmanship. With our service team, when they go onto systems, and majority of the systems that they do service work on are systems other people build. And a lot of their issues is not inverters, modules, it is the workmanship. It was how it was constructed. They have to correct things. There's wear and tear that's taking place because from the get-go, quality control was not in place. And so with us, we know that is essential. And in our field staff, there's daily logs, there's task-specific forms that they fill out those logs, and right there is a list of all the different QA, QC forms that are utilized in the field when we are on site doing every step of the construction. If you flip the next slide, you can kind of see, like one thing is torque markings. When we go do an annual maintenance on the system, how would you ever know if a bolt is not where it's supposed to be or it's loose? We mark every single component. We use pens that we know if there's ever an issue. The next one will show that we use gel pens for any electrical components. So make sure those terminations, they all have to be torque to spec. If they're not torque to spec, it's not going to be warranted. The manufacturer is not going to void the warranty because it wasn't torqued to spec. Next one. One big thing is also wire management. The wind's going to blow, wires are going to go everywhere. If it's ever going to rub up against a sharp piece of metal, eventually it's going to have issues. So excellent wire management. We have a systematic way of how we say all our strings are to be wired in the field, quality control in those forms that we fill out. The next thing is with testing procedures. There's a lot of conductors. We make sure as we go through, we're doing IV curve tracing, Mayer testing of everything, open voltage testing. We're testing, make sure the conductors are doing what they're supposed to do, and it's ready to perform as it should. Last thing is the cost and cash flow. It was shared with the bidders, kind of how the city was looking at the project. Able to buy less power from RPGI and take out in the form that was, or the spreadsheet that was given, it was a hypothetical 15-year 4% loan. And so we were able to use that to just try to see what is the best size system for positive cash flow. So day one, what will cash flow? And that's what we came up with, is this size system. And if you take a 15-year loan at 4%, there's the debt, and then the cash flow because of the savings the system will provide. And that was based on just taking our production estimate into the spreadsheet that was provided by the savings from RPGI and calculating that net cash flow. And if you extrapolate that over 30 years, we just put that together, next one, to see, what is the net cost savings during the loan? It's going to be a positive cash flow. Now, I know this is very simplified, and you got other factors with insurance, all that kind of stuff to factor in, but that's what we had to look at. And this does not include any RPGI cost escalators. Their electricity is going to go up, and so your savings is just going to go up as well, but your loan terms should not change. Next slide. So our project and our proposal that we looked at is, hit those four things, and I think that's why it's the best value for the city, or the quality of the equipment we're going to use, optimal design and production, the longevity of the system. It's going to be functioning correctly from the get-go. We're going to have quality control in place, excellent workmanship so that it performs as it should for decades to come, and the best balance between system cost and cash flow initially and long-term. That's what we have to provide to you. And do you have any questions? If there are questions.
You talked about the panels having the top side and the bottom side. What do you actually get from the bottom? I mean, roughly.
It depends on the albedo of the ground, which is the reflectivity of the ground. And so I've had systems where I've monitored and look at them, and when you get a light snow, you can see the next day it spikes up. It can be up to 20-25%, but that's in the factory settings where they're testing it that way. But out in the field, it's maybe 5%. It's hard to say. It just depends on what the ground looks like at the time.
And that's why we don't put it in our production.
No, I get it.
Yeah, it's just bonus. It's icing on the cake. Yeah.
Maybe we can distribute it to the council members.
There you go.
Let's do it. Come in.
You in? I have one other question.
What's the life expectancy on everything?
Of the system.
Yeah.
And so in the life of the system, in the 30 years, the inverters are going to need to be replaced. And so that is the component that's going to need to be replaced. The modules, there's modules that for 30 years ago, they're, the first modules, they're still going, and that's so much better today in terms of their longevity.
Okay.
So the modules come from the manufacturer, 30-year performance warranty.
Okay.
But the inverters have a lifespan of about 15 years.
Okay.
And so in the life of the system, that is something that's going to need to be replaced in the future. And in terms of the cost of the system, the inverters is, a small percentage. The large percentage is racking and modules, and obviously the AC gear and labor.
I thought you had 10-year warranty on module, on the inverter itself.
From the manufacturer, 10-year
10
warranty.
year.
Yep, 10-year warranty. It can be extended up to 25.
And what is the maintenance as far as yearly?
You need to have it typically yearly.
There's no plan involved in this bid right now.
We do not have it included, but we did provide to the city in the RFP, there was the option of an annual check, make sure everything's where that's what we had in that RFP. We included that in the exceptions section. But yeah, especially with warranties, the manufacturer's typically going to have, it's got to have its, regular service timeline so that it can maintain its warranties.
Is there warranty on your actual work itself?
Correct. Yeah, there's warranty on our work, is what 1 year workmanship, but
When you're working.
with the RFP, we had to include as a 2-year warranty.
Okay.
Yeah. If, in our experience, if anything's going to go wrong with the system, it's going to be in the first year, because that's when you got a faulty inverter. And that's going to be covered in that first year. We're going to take care of that.
How about maintenance underneath the panels? Just, we talking weed eater?
Since it is a pollinator mix, it's made so it will not grow above 30 inches.
So it's a low growth mix, and it's common on a lot of the solar arrays that we see.
What is your yearly maintenance plan? How much is that?
I can't remember. I think it was $2 a watt
$2 a watt.
to do our annual maintenance and then also our annual monitoring. We monitor it for you and come do that yearly maintenance to make sure everything's working as it should. I think it was in our RFP, $2 a watt.
Okay.
And we have, like Crystal has a detailed checklist, which she goes on site. These are the things, we can share that. These are the things we're going to be checking, and you're going to get a report that this is what we see with the system.
It's $1.80.
Yeah, it was $1.80 plus the maintenance, not the monitoring was another 20 cents.
Oh, yeah.
Yep. So it was $2 for those total.
But those go through year 4, right?
Yeah, at year 4, they would, based on market and,
Yeah.
we can't lock in that for 30 years rates, or rates for employees.
Now, just so we're clear about what's changed, when your proposal was $1,499,400. So now it's what?
Roughly 17,000 more, yeah. And that is based on 10% tariff went through, and then going back to our gear, people that provide our gear, we said, update the quote, please. And everyone is seeing prices go up. We know our subs, in terms of fence and driver moving the dirt and all that stuff, they're locked in until like the end of the month. They said after this, we're going to have to adjust it just because they're going to have extra costs. And the fence, we know, is, the metal, steel is going to go up as well. So
It's a high volatility market right now.
everything is,
Everybody knows.
it is literally week to week and sometimes day to day with, especially in the module pricing world, with reciprocal tariffs coming across the board.
Are there any panels that are more efficient than 22.5%?
There are, typically they're going to be like a residential type module, which, you want the highest efficiency, you only have so much area, so
Right.
that's going to be your, but yeah, usually 23% is going to be what you're going to top out at. That's on the market currently.
Okay.
And right now you have no problem as far as getting a hold of the materials?
No problem.
Locked
This
in there?
point, yeah.
Okay.
Yeah, and we really can't lock in pricing until
Right.
it's contracted and we place our PO. Because PO's 2 days away and prices go up. We just can't, we cannot control what's going to go on with equipment.
In the middle of September, 1st of October, as far as the plan.
Yeah, we could, if it's contracted in the next 7 days, that's what our plan would be. It would be done being built in the middle of September. It would just be all the final checkoffs, commissioning the system and closeout. That would take place at that October.
Does your maintenance include travel time? There's no travel time on top of that for a technician to come out or whatever?
For that annual maintenance?
Yeah.
Yeah, that
That's
is.
included.
That's included in
We
there.
could get them on site for that annual maintenance, yep.
All of our laborers are local, so.
Any other questions? John, you got any questions?
Yes and no. How much is there on-hand training for local staffing? I mean, eventually, we'll be responsible for all this down the road. I mean, years down the road. I mean, you guys are there now, but down the road, we gotta know what we're still doing with it. I mean, is there any training that you guys provide our local staffing?
Yep, and that's what we include that. When we started up, we will train, here's what you look for, here are the breakers. If you have this ever happens, turn this breaker on, turn the breaker off to reset, things that, we'll do that type of walk through to show you how it all works. Now, an actual 8-hour school day to learn how to do it all, we are fully capable of doing that. It's just a matter of what do you guys need?
I mean, eventually you guys will be free and clear of it, if you will. I mean, 15, 20, 30 years down the road, and we're still gonna have it, so
Yep.
that's where this is coming from. We need to know kind of the ins and outs. I don't know if there's like shadowing when you guys come and do your stuff, so we can actually see what you guys are doing. I mean, is that a possibility?
Yeah, I mean, we can go through all the training at the end of the project. I mean, if you want to know how to swap a module out or.
Yeah, I'm not saying we're doing it, but I mean, eventually it could come down to we're the ones doing it.
Sure, yeah. I would say, if you were gonna do maintenance on it, like swapping modules, I would probably have somebody that knows what they're doing on solar come out and swap it. Just because that DC voltage is always live.
Yeah.
So it's,
Yep.
there's a certain way to do it.
Yep.
But yeah, I mean, we'll provide as much training as you need to make sure you're comfortable with the system. It's pretty common practice with any system owner that we're dealing with, is they want to know, maintenance team wants to know how to operate it, so.
Exactly.
And we've got everyone's stuff, like, all we do is solar. So if there's ever questions, if you shoot us an email, we're not gonna charge you to answer your email. It's a matter of, what do you need is really what we would need to know. What do you need to be able to, really carry the baton?
Yeah, it's not like I'm expecting you guys to walk away from this area. I mean, you guys have been here for a long time. Yeah, I don't see you guys going anywhere. We've used it for many projects. So it's just better for our staffing if we had a better understanding of what we're looking at when we go up there and we have to do something.
You want to feel comfortable with the system.
Exactly.
Yeah, it's your asset.
Yep.
Yep, and you're gonna get as-built, so you're gonna know where everything is, what it looks like, what's underground, where things are underground. So you're gonna get all that, so you have a comprehensive knowledge of what the asset is.
I thought I heard at the beginning, you mentioned, or maybe I misunderstood, but you've done something that has a higher kilowatt hour production than what was in your proposal. Did I catch that right or no? Is it the same as it was in your?
No, that's why we chose those inverters, because it's gonna produce the most power just because of the type of inverters they are, in terms of the more MPPTs, the more potential for making, especially on cloudy days. When clouds go over, if you ever seen clouds go over a countryside, you can see the clouds move over a large area. What happens when that goes over a solar array? If one row is on one MPPT, that means if one module shaded, it's going to bring down that entire row. But if only one module shaded and it's only going to affect these 15 modules, the rest is going to function. So over 30 years, that's a lot of savings.
Where do the solar panels go if they go bad? I mean, do you take them to the transfer station or? So what's that cost? I mean, I'm asking, I have no idea.
So, like on a very large site, some of the other sites, like 5 megawatt sites, typically like 1% of our modules that are broken from shipping. And so we have to go through a recycling process.
Mhm.
So a company will come up, we, use reputable companies that will come in from out of state and take them and decommission them. And however they recycle, they take out the glass, they take out the silver and all that and recycle the whole module. You can't send it to the landfill.
Oh, that's,
Yeah, it's.
I didn't know what you
toxic.
got rid of them.
So-
Or what you did with them when they were, or
Yeah, so we usually do like bulk recycling, so over course of
Yep.
6 months, get a whole bulk order and then get it recycled.
Mhm.
And we assume when these modules, if they were to get delivered, there would be some breakage. And so we factor that in. We know we're going to take those offsite and
Absolutely.
recycle them.
Anything else?
What, just like if when we take these over and one was to break, we had to repair, what does it cost to get rid of that? I mean, what's that recycle fee or whatever?
I'd have to double check on that because we do such large orders.
Right.
I did check with, and we don't use it, but it's Scott County Waste, and they're $3 a pound to
Sure.
recycle it.
Okay.
But they have to take it and ship it off.
Get rid of it.
So,
Yep.
but that's not what we do for bulk order. So it's-
Yep.
So it's $3 per pound. So a module maybe weighs 50 pounds. So,
Right.
yeah.
150 bucks.
So we just drive it in the pickup truck down to you, let you do it.
There you go.
After hours.
John, put that in your pickup truck, bud.
All right.
Is
Thank
there, is there any monitoring over time for, we'll just say heavy metal leakage or anything like that? Not everything in there is earth friendly. I mean, yes, it comes from earth, but there's heavy metals, and we do have a Sager system in the water plant just down the hill.
I don't have any historical data that I could share. I know these are double pane glass, so there's glass on the front and the back. So that's all I know about these modules is the opportunity for leakage is going to be very minimal because of
I
how
mean,
it's
I
constructed.
would assume it'd be more if there was a breakage and you'd have material on the ground.
Yeah.
But a lot of that stuff is heavy metal, and heavy metals don't just sit on the ground, they leach in, so.
Yeah.
That's what I'm asking.
Yeah, and I haven't seen any of that.
I don't know any data that, you know,
Okay.
I've never heard anybody raise that as a concern that the modules, the leakage or the seepage into the,
Years ago, when this stuff first came out, there was a lot of heavy metals in there, and there's nowhere to recycle them or take them even to a landfill because it's heavy metals. I mean, I don't know how you handle them.
Yeah.
So I just want to make sure that whatever is in there, if it was broken on the ground, we don't end up contaminating downstream, because I mean, we have our wetlands, we have our Sager system, our treatment plant right down there.
Yeah.
May not be an issue, but just thought I'd bring it up.
and when these, I've seen modules actually break. If they do break, it's tempered glass. So it's like a windshield. It doesn't just shatter in a million pieces. It just,
Not
It
just
looks
the
like a
glass,
windshield.
though,
it will.
it's the photo underneath it that's got the heavy metal.
Yep.
That's what you guys are talking about, recycling the silver and whatnot.
But the glass all sticks together, like stays together. So, it is super durable. I mean, I know, a couple years ago, we had like 2-inch hail come through Davenport. And I was worried about our rooftop, system on our building. Got up there, not a single module was broken. And they had 2-inch hail. All of our cars were ruined in the parking lot. The glass on the modules were fine.
I have a similar story. We installed a system for another company I worked for a long time ago. It's, you know, it was like 2-inch hail in like Fort Dodge, and there was a metal building. Well, beat up the metal, so the insurance company had to pay to replace the metal on the roof. The modules were fine, so you take all the modules off and replace the metal and put the modules back on. But that just shows you how durable they are. A roof is going to go bad from hail before the modules will.
Anything else?
Is it possible to email me your slides in case the council wants to review them again?
Yep, definitely. Can do that. I also have hard copies of the data sheets of the equipment if you want those, and an updated proposal with that price and our scope of work. That I have hard copies of that as well.
And you have that now?
Yep, they're right here.
Thank you, everyone. We appreciate it.
Thank you.
Yeah, yeah. All right.
Any questions?
Yeah, it's like silence and every time I ask. It's all right.
It's all good.
Yeah,
Thanks. I'm wounded. Where's her?
I'm sorry. Any questions?
Yeah, the water.
Good set.
Yeah.
That's gonna leave a mark.
Uh-huh.
And we were forgetting to use never.
Yeah. Oh, perfect.
In front of the fire. Which person, 25 footer, which person you want me to be?
Pick your poison.
Not fair.
There's an HDMI coming out the back already.
So.
Is it on already? Yeah.
Am I out of the way there?
Oh, yeah.
Yeah, thank you.
Good. First, want to introduce myself, Randy Shoemaker with Custom Builders. I know most everybody here, but in case you don't know me, this is Don Roth with Roth Electric and Tim Dwight with Solar Integrators. We team up together. We've done a few projects already. Tim and I have got a little more history, but Don's done it for the last few years with us too on the electrical side. And first and foremost, we want to thank you guys for letting us bid it, you know, being in town and being right here. We were just happy to have bid. And sorry about the way the RFP went, and I hope everything gets settled tonight and for you guys, and we can move forward, or you guys can move forward. So, the way we set this up as a partnership, one of us just takes the lead as a general. I'm general on this one because we're in town, and then obviously we have Solar Integrators brought in to do all the engineering and the layout for the system and size it and do all that stuff. And Don obviously is the whole piece on the electrical side, all the gear, all the wiring and all that stuff. So we've had a lot of good success doing it that way. We don't, not any one of us has to specialize in the whole thing. Like we talked about different times. We all have our strengths, and then we collaborate together. So, yeah.
All right, so we'll just get into the project overview here. And some of this, might get repeated between Tim and myself and Randy, but we'll just start with the project overview. So we sized it at 1.25 on the DC side to a 1 megawatt AC side. Well, you might ask yourself, well, why do you do a 2.25 to 1 ratio, right? Well, we're trying to maximize production. So there's different sun angles depending on the season, and you're trying to maximize that output. You want to get that 1 megawatt of AC out as often as possible. Other companies have different philosophies behind that. This seems to work very well for us. So our system produces roughly 175 million kilowatt hours a year of clean electricity, offsets 1,240 metric tons of CO2 annually, and delivers $3.3 million in energy savings over the next 3 years. So the template that I put together that we're going to jump into here next, you guys don't have a pointer or anything, do you? No?
I
can go
got
up
10 of
and
them.
help.
So that savings is what you will not have to purchase from your wholesale power provider currently, right? So it's not a check in pocket annually. It's offsetting costs. That's what that represents there. So, and then I threw in here, if the rates remain the same as they are today, and I estimated conservatively, I don't know exactly what your guys' wholesale rate, blended rate is, but I think I have a pretty good idea. And I didn't factor in financing, interest fees or anything like that. I just did across the board, right? So that's where I come up with this rate of return in 10 years based off of our parameters and projected production. So jump out of here.
Any questions so far? And, you know, we're trying to fly about 10,000 feet right now. If you guys want us to get down into the weeds, we'll get as deep as you want to go. We just don't want to overwhelm you. We just want to point out the high points of the project, right? So. Didn't pop up. Not sure.
Close that out. I'll let you know.
Technical difficulty.
Close out your PowerPoint. You have to close it out, like exit.
Maybe I won't show you.
Yes.
All right, can everybody see that okay?
Yeah.
So I sent over a version of this last night, which I think Brian forwarded to you guys. Hopefully you had a chance to review it. Hopefully it made some sense. But like I said, there's no financing factored in here. All we're looking at is system compared to system. So up here you have basically a 1.25 system compared to a 1.12 system. So based off that, you have your system cost right here that was submitted to you guys for the project. So what we do is we take this cost divided by your DCs, you come up with how much is it per watt. That's how we price these things out in our industry. So it's always based off the DC side, not the AC side. So then you factor in here, so here's our cost variance, right? So currently we sit about $173,000 higher than Tri-City. You throw in your 30% tax credit, which you guys are eligible for. Now that narrows the gap down to about $120,000. This is that wholesale power cost. Am I in the ballpark there, Brian?
What is it?
6.5 cents.
It's high, but we're at 52.
Okay. So basically, as this number fluctuates, that impacts this number, right? So if that number goes down a little bit, but it should go down the same compared to both systems. So, and we can change that number for illustration to show you guys. So here's what our savings is based off this right here. It's roughly about $7,000 more a year than the competitor that they propose, right? Then we kind of glance over here, and this is your 30-year evaluation, comes to about $215,000. Now that isn't factoring in degradation. Are you guys familiar with that? So I mean, panels produce less over their life cycle.
And yours was set up at, what was it on yours?
So ours is at 0.02%. So 0.2% is what our degradation is.
And at the end of 30 years, what was yours?
So at the end of the 30 years, we're still producing 1,650,000 kilowatt hours annually. Which you look over here, year one, they're projected to produce less in year one than what we're projected to produce in year 30.
And
So,
that's due to technology that we have in our module.
so now we throw on these degradation factors in here. And I did make one change from the spreadsheet you guys might have. Their degradation was actually 0.5%. And I think I had 1% on my example. So I changed that. Our degradation is 0.2%. So you can look over the next 30 years of what the payback looks like. And I just summed it up right over here. So after 30 years, our payback or our system will outperform their system by about $318,000. That's based off that wholesale power cost that I threw in there. So we can knock that down to about 5.5 cents or what John mentioned. And then that might close that gap a little bit, but it won't close it all the way. So the other thing we want to point out, so we basically have 300 more panels than they do, and then we have 12 less inverters, right? So the less inverters, the less line losses, the less losses on your system, the better performance, the least amount of failure points. So Any questions on this here?
Does that mean more panels to an inverter though?
Correct.
So if an inverter goes out, more panels go out.
Correct.
But Tim will jump into the inverters here in a second, which will hopefully answer those questions. So, any more questions on here? Makes sense? I mean, basically, that's what the city's looking for, right? What's the biggest bang for the buck? Now, you can throw in financing. That's where the accountants come in. I'm not an accountant, so I left the financing out because I don't know how you guys are going to finance the project.
I mean, if you look at the dollar per watt, it's pretty much the same. We just oversized our DC for certain reasons. So it's pretty much a apples to apples.
Right, so we're 1 cent less of a KW base or a watt.
So if we would lower our DC, it would be the same, pretty much the same cost, the same price point as they are.
So,
It's the same dollar per watt.
all right, we'll jump back over here. I'll let Tim take the floor.
Thanks. Okay, so I've been in this industry since 2008, all right? And just to let you know, modules used to cost $4 a watt. We're installing the system for $1.25 and everything. So I've been in the industry where solar was really, really expensive. And now through technology advancements, just pretty much scalability on manufacturing scale, because we're producing a lot more modules than we were 10, 15 years ago. It's amazing how many gigawatts we put in the market last year, like 600 gigawatts in the world, which is staggering. So I've always looked for advantage. You know, we've always been trying to drive down costs. You know, we knew the modules eventually going to catch up, but always looking for opportunity to drive down costs, especially here in Iowa, because people thought I was crazy coming to do solar here because we have really low energy rates compared to California on the East Coast as well. So it's been really hard to sell decent sized projects in Alliant, but bigger projects in the REC markets, municipality markets, because the kilowatt rate is so low. But since modules have dropped, we've kind of gotten a little more attractive to the end user. So I've always tried to find advantages to bring down costs as well as technology advances. You know, in solar, the last number of years, the cell has kind of increased about 1 to 1.5% efficiency. If you look back, I was selling efficiency of 13%. Now we're in the low 20s. We're gonna, in this module. So I've been always looking for better product as well as durability, reliability, production, because, you know, I'm kind of known around here, so I put my name behind a lot of things, you know, and I don't want to be selling crap to people. I'm going to sell real value to people. And this module is the real value add. And it's probably the difference a little bit. It's difference in the production as well as reliability independently. And I've learned a lot about this module. So you can see, you know, we're at 22.5% efficiency rate, so that's about 1% more than the competitor's module. What you really got to look at though is the degradation rates. You know, and this module is 100% PID free and LID free. So PID is potential induced degradation. Okay, so that happens when you put this first solar cell in the sun, and the sun will beat that first solar cell for a year. The first year really drives it down. Well, this cell does not do that. And that's the reason we have a graphene layer on top of this cell, and that's the difference maker in the market. There's no other module like this in the world that compete with this module. They shoot bullets through this module, and the module still operates. So the durability is really strong. And the degradation rate is really strong as well. As you can see, it's half the degradation rate. So our module at 550 watts will be 550 in 30 years. It's actually about a 610 to 650 watt module of a 550 watt cell, because of the graphene cell inside it pumps up the efficiencies on the production. And then LID is light induced, so that's from the sun as well. PID actually is from the cell. The cell has a tendency to leak out into the module, so you lose production. So this technology has 100% anti that, so you're not losing any light induced or PID, as well as, you know, graphene is a lot stronger than steel. And we have the way that they design this cell, if you look at it, if you look at a lot of other cells, there's these things called bus bars. And that's how the electron jumps off the cell and goes into the module and goes out to the inverter, and it gets changed in from DC to AC, right? So those bus bars cover up the cells. That creates shading as well as less area to grab the photon. Well, these cells are nanofibers, so they're like 100 times thinner than your hair. So I have hair, I can't point one. But yeah, so they're super small, but they have millions of contact points in the cell. So there's millions of more highways for that electron to get off, and that's why the yield is so much better than the other cell that you're looking at. Where the other cell might have 150 to maybe 175 contact points, this have millions. So you're yielding a lot more than the traditional solar cell that you see in the market. And I've been looking around for solar, all kinds of different technologies. And there's another technology that's coming out here in the market that might do something, but they haven't scaled it yet. And we're kind of waiting on that, which might be introduced into this module, but I think it's years away. So that kind of breaks down on what the solar module, the difference in that is the graphene cell really promotes a lot more yield in the production, as well as, you want reliability and durability. I mean, at 30, I asked these guys, I said, well, what's your module degradation at 60 years? He said 85%. So at 60 years, we're at 85%, where the other module at 30 years are at 85%. So we're at the same percentage 30 more years later than the other module. So this module is going to sit in the field for you for a long time and produce a lot of energy for you. And the reason, so that's kind of a module. You can get the big inverter. So like when we looked at the system, inverters change too. And so you always try to design systems with least failure points because, you just want a lot of things going down, right? So that's what we did with this project. And I just did a 2 megawatt project for a big hog processor up in Laverne that use these inverters on. And they're a big difference maker than the traditional like PVI 60 TLs with Selectric had out, which we did a lot of smaller commercial with that, as well as the megawatt project that we did in Kelowna. We used that 60. But I moved into a little bit bigger of an inverter for like smaller megawatt size systems because the failure points, the efficiencies of the install is a lot easier. Instead of 16 inverters out there and then actually a disconnect switch too as well, this is all built into that inverter. So the install was a lot cleaner, it's a lot faster, it's less failure points. So the neat thing about these inverters is we're going to have a replacement kit on site. So if an inverter goes down, all we have to do is Don's going to show up, flip up the inverter, get on the phone with Selectria. We're going to do a diagnostic test, and they'll have the pieces right there to swap out right on site. So your downtime is going to be a lot less than it would be with just PVI 60s. PVI 60s, what they do on, because I've had to replace a couple, is they basically have to take the inverter head off, you ship it into Selectria, and a couple of days later, they ship you a new one back. So instead of being down hours, you're going to be down days with these other inverters. Plus you have 12 more inverters out there that have the opportunity to fail in. So you've minimized the O&M as well as downtime with these inverters, as well as, they're just about as efficient as the other ones. I think the other ones are 98%. These are 98%. I mean, they're made by the same manufacturer. Our inverters are made in Buffalo Grove, Illinois. Those other inverters are made in Malaysia. So we're US made. I mean, we're racks US made. Our modules aren't US made because not a lot of module manufacturers are US. There have been some here, and there still are. Chinese they scaled a lot. They've taken out a lot of our manufacturers, but we're trying to bring that back. I mean, if you see some of the modules that have been built in the country, it's by Hanwha, which they were a German Q-cells, which they were a German manufacturer for many years. They got bought out by Hanwha, so now they have manufacturing in Georgia. Jinko, which is a Chinese company, they came into the south to Georgia to build a manufacturing plant, or they're in Florida. And then you've got like a company called Canadian Solar. They're out of Texas. They do 20,000 modules a day. So you're seeing a lot of these manufacturers come in here, but as a 100% made module, we do not have that right now. But I don't want to try to buy Chinese as much anymore. I've always looked for an opposite.
What did you say was made in Illinois?
The inverter.
The inverters are made in Illinois.
The inverter. And this module is made out of Poland. And these guys have been in the industry for 19 years. They've got lots and lots of sites. They've got sites where you've got a Jinko module and the PV graph module, and you can see the differences in production. I mean, it's pretty significant. Especially in like really hot climates, they're doing like 2 kilowatt hours per kilowatt, which is quite a bit. Here in Iowa, on a traditional module, we're doing about 1,300 kilowatt hours. With this module, we're doing about 1,500 to 1,600 kilowatt hours. So it's quite a bit different when you extrapolate that over thousands of kilowatt hours or millions of kilowatt hours over 30, 40, 50 years. And that's, our plan.
Just the module was made in China, right?
This model's made in Poland.
Oh,
Yeah, Poland. They're debt-free. I've actually asked them, because there was a company that was in Iowa City that actually bought the manufacturing machines from Mission Solar and stuck it in Iowa City, and then they went bankrupt. So I had a friend of mine ask me, because his dad owns this building, he's like, hey, can you build these solar modules? And I'm like, well, it's kind of a different animal, because I've seen a lot of module manufacturers come in and go. And then I was like, hey, maybe we could get this PV Graph to come over, and maybe we could stick their cell in an Iowa-made module. So I kind of talked about that, so that's something we're kind of maybe progressing. But the module manufacturing field is very, very aggressive, and it's very, very competitive. And like I said, I've seen a lot go. I'd rather implement the technology than actually own that technology, because technology can get jumped. And you're going to start seeing that. This module is going to keep evolving, just like our cell phone evolved. I mean, 30 years ago, I would have told you had all these apps, and you could take pictures and do all that stuff, and you guys would have been like, no way. And look what we've done to our phones. This module is going to evolve as the market opens up. So you can, next slide. So just to give you an idea on the DC side, how we size things. So it's all about yield in solar, right? Just like corn, just like soybeans. So they make these inverters to drive them higher than their nameplate. So that's why you always see the DC higher than the AC. Because we want to get these inverters up as soon as we can, and we're going to run them as long as we can to the end of the day, so we can get a lot more yield. So that's why we spec'd our 1.3 megawatts to a megawatt AC. So when the RFP came out, you all asked for a megawatt AC. So we spec'd the 200s times 5 is your megawatt. And then you can actually drive these inverters longer than that, like bigger than that if you wanted to, but we wanted to hit your kilowatt hour goal for the years. That's why we went to 1.3. You can actually oversize them a lot more than what we have. So it's kind of, yeah, so there's a lot of advantages with these inverters and these modules than what you see typically in the market.
So we're just back to the financial impact. We reviewed the $3.3 million of cost savings over the 30-year life cycle. And, as Tim mentioned, you're going to get, additional 30 years out of these panels, and they'll only be at 85%. So you can only almost take that number and double it. 'Cause one thing that was not factored in here was wholesale cost increase, right? Which we all know that costs go up, right? And it's just a matter of time. And it seems to be happening more often now than what it has been historically. I mean, so that's just a fact. We talked about the 10-year return a little bit. Now it's like, why does the city want to invest in this project, right? Well, these are my assumptions. You guys want to reduce your energy costs. So and how can you do that? And you can invest in solar. Solar is predictable. It's a one-time capital investment. So them are ways to stabilize your energy costs for the community, right? And we benefit from that also, being from the community. So and then long-term reduction, municipal utility expenses, you're lowering your operating costs, you're reducing your peak demands, and once again, reducing your purchase energy. So it's a win-win for the community and those that live within the community. Now we're back. I'll let Randy take this slide here. So we're just back to the local service, long-term support. We're both locally owned and served.
Once again, we obviously are more grateful of having the opportunity to come present to you guys, because we believe in this thing. I mean, we wanted to bid it because we believe that this is a good thing for our community. And we also, we're here long-term. You guys are here long-term. We want to be here. And, with Tim's help on the equipment side, we feel like we've got the best equipment for our community. And we also feel like we got the equipment that's going to allow us over the long term to have the least amount of downtime or problems. And that's kind of the way we design our systems. So.
Yeah, this isn't a one and done project for us. This is all about building that alliance with the community that we live in, right? We're trusted contractors within the community, and we plan to be here for a long time. Short response time. I mean, we're both within a couple blocks of the site, so we can be there in pretty quick, short order. So And I think, this is the last one here, just to recap what we spoke about earlier, the initial cost comparison. We're approximately $174,000 higher than the competitor right out of the gate. Factor in their tax credits, it brings us down to about $120,000. Over the 30 years of the system, we're gonna outperform by over $300,000 based off those calculations. That number is incorrect after I made the adjustment out in the hall, so it's closer to about 350 according to that spreadsheet. So higher efficiency, lower degradation to ensure stronger return on investment. Solar performance, we mentioned that already. So another thing I guess I'd like to mention is, one thing we like to estimate conservatively, but with this new technology that Tim keeps referencing, our panels are projected to even increase production by 10 to 15%. And he should have those numbers hopefully tomorrow at some point.
Yeah, right now the models don't calculate the graphing cell into them. So we use this company's called Akita for solar graph, where we get online, we have accounts, and we can build out our proposals and things. And they have production and report engines built into them, but they don't have this cell built in, because I sent the production over to these guys. I'm like, oh, you're way off. We're going to produce way more power than that. So they can produce that for us. I request that. It takes about 24 hours to do that. So tomorrow they're going to have a real report done by them on the technology, on what the productions can be here.
What's the maintenance as far as warranty on your equipment?
We have 10 years on the inverters, which is kind of standard. And then we've got 25 years on the module. I think it's a 30-year. I think it's a 30-year warranty on the module, 30-year workmanship too. Back in the day, it used to be like 80%, and then maybe like 10% on workman. Now we've kind of, as the industry's grown, manufacturers are starting to put better materials in modules, so their performance guarantees have gone up. Usually a module drops about 2% to 3% the first year, and then it degrades out its degradation rate. And then the work and the quality of the module frame, you've gone from 10 to 15. And some like companies like LG that I used to do a lot of, they're out of the market now because they just didn't want to dive down to the bottom on low cost. They had really good modules, and I think their workmanship was 30 years as well. So there's been some good players in the market. It's just that the Chinese have really driven down costs, and you see these big, huge projects out in California, and all they care about is the returns, right? So they have really low-cost Chinese modules out there. That's where they're manufacturing.
So a
Really
couple
running
of,
out pay stars. But, no,
couple of things we should point out. We feel if the council made a decision to move forward, we would have no issues meeting that October deadline. I will mention that there are cost increases that are coming. So we all reached out to our manufacturers that we deal with. As far as mine on the electrical side, I'm being told May 4th, I should see an 8 to 10% increase. So if we order prior to May 4th, then we can lock in the prices that we've submitted today. Now, when I say 8 to 10%, I'm only talking about one leg of the project. That doesn't mean that whole project goes up 10%. It's just my portion. So
Right now, your proposal is still the same.
Correct.
Correct.
Yep, and we're all comfortable with that, basically, through the first part of May.
I mean, this system should go in pretty quickly. We have 5 inverters. I just installed 6 inverter system, 2 megawatts up in the burn, and that was on 2 meters. And we had when we were over like 7 or 8 acres, so we had a hill in the middle. Some of our inverters were down here at the hill, so we had to put a lot of AC up, and we drove another 760 feet of 500 MCM big wire, which is pretty big wire to pull. We started in November, and we were pretty much done by January 5th. And this is Laverne, Minnesota, where it was windy and cold for these guys up there working every day. So if we're working in May and June, I mean, I see us.
So your projection is still on track then?
Yeah,
We are.
I mean,
Yep.
we should have this thing pretty much ready and buttoned up by the end of July. We get equipment in sight and roof, everything shows up by the end of May, it goes in pretty fast. We've got a good guy that drives these piers. He drives piers for mostly everybody in the state. And then Randy's crew, and we built projects for Maine. They've done a great job, and they've gone really quick, which is great. It's usually the electrician you're always waiting on, But they gotta pull all the wire and make sure all that's correct and.
He's gonna be, you gonna be fully trained on the SOP system anyway before you leave, right? So where are you based out of?
I'm at Iowa City.
Right, okay.
Yeah.
John, what were you saying about tax credits in your model?
I'm saying if you take the 30% tax credit and apply it against the system cost, then that closes that gap, because their credit's gonna be, I think, was 499,000 and ours was $50,000 more. Just, 30% of system cost is 30%, so ours is gonna be more of a tax credit than the other competitors' pricing.
But both would still be 30.
Correct.
They're both 30%,
Correct.
you're just taking 30% off of a
Basically,
larger number.
30% is a bigger.
Yeah, you're
number
saving
from a bigger-
30% of that 174,000 difference. You're saving off that tax credit.
All right, so we start off at roughly 170,000 higher, and time you factor in tax credits, it shrinks that down to 120.
Now, the other thing I think about these inverters, they have a remote access portal now. So like I can get on my phone right now and I can look at these inverters and I can look at what the DC voltage is coming in, the AC voltage on each leg coming in. What my production is, how many kilowatt hours. I can control these inverters. I can shut them down. I can turn them off. I can run reports. I mean, it's pretty amazing the granularity now that you can have with this new type of platform that Selectree's created. Can't do that with the PVI 60s.
So that kind of leads us into, the monitoring. So it's even better with this new technology, whether you monitor it in-house or you have us monitor it remotely, or we do it at the same time, they're easy to monitor. So
You get your own account. You can put all your own users on there. So if the inverter goes down, you give them a line, and then you can just pull it right up there on your phone. It can tell you exactly what area code that is. And then boom, you have the site and you already know kind of what's happening, what to look for. So it kind of cuts down your downtime. And then you have that kit. So they made everything interchangeable in this inverter. So if you got like an arc fault meter out or something like that, or an internal piece, you got it right there. You're just swapping it out. And he's going to go down to Buffalo Grove for 3 days and learn how to train on that. So he'll be a fully functional technician that can own this systems. The only part that really fails in solar is the inverter. The modules really don't fail a lot. You got maybe 1 to 2% failure rate in the module. It's usually an inverter that drops off because it's doing all the work to.
How long will those usually last?
Well, I've been smart. I think, I'm trying to think, the oldest sites I have right now is Allen Valley. That was 2013. I think I replaced one inverter. So 12 to 15 years, I think. Now, a lot of this stuff's interchangeable. So this inverter probably is going to run 20 years. It just depends on pieces you got to replace. But it'll typically be the same inverter. It's just some of those pieces might be switched out in the life cycle.
and I'm getting in the weeds here, but technology advancements, I mean, back 10 years ago, if you had one solar panel go down, that was the weakest link in the chain, right? So the whole system produced at whatever that weakest link could produce that. Well, that technology isn't like that anymore. It's still producing where it's supposed to be producing, even though there may be one failure with one cell and one panel. So.
Just to be clear, if I understood you right, the RFP number that you quoted was $1 million, $1,672,875, and you're looking for that to stay the same at least until, did you say May 4th? Is that accurate?
Right, May 4th, on my end, right, I could see I'm gonna see an 8 to 10% increase, but, you're talking somewhere between 10 to 20,000 increase on the electrical end. But I don't know if that impacts these guys at all. I don't think they have any increase coming up.
Not at this point, you got that 90-day pause. So it all depends kind of what's happening down.
It'll be, the racking, we'll have to kind of watch that because the steel prices, but.
For the latest, we're gonna make, the very latest date, we're gonna make it a decision is Monday night. So
Yeah.
we're well within everybody's.
Yeah.
So what's your biggest selling point for us to go with a little higher price one? What's the one thing that stands out there?
The solar module.
Longevity of the system.
And
The
the
production.
modules that you have yourself, you're fine.
And the, I don't know, I think of the inverters too. I mean, instead of having 16 out there, you got 5 out there. And they're pretty, I mean, the downtime is gonna be a lot less. You don't have to take an inverter head off and ship it out, do another and ship back. It takes about 3 or 4, maybe 5 days.
Trying to think how to put it in perspective, it's like if you got a 24-row planter, are you a farmer?
Nope.
Oh.
It doesn't work.
So we have fewer fail points, right? So we have 5 fail points versus 17 fail points. So that in itself is a big plus. I mean, trying to minimize those fail points. If the inverters are the pieces of the puzzle that fail, well, let's minimize those inverters and still maximize the output. And that's what we're doing here. And now we've replaced it with an inverter that basically you can get under that hood and you can fix it versus a replacement, you know, so.
When Brian asked about your cost, and the RP is the 1672, blah, 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 it actually is not, correct? Isn't it the 17, I lost it. 1749,
I
113?
think that's the production.
That's the kilowatt hours.
That's the kilowatt hour.
Kilowatt hours. That's the actual production in kilowatt hours that we're gonna have over what they're.
Our system proposal is 1,672,875.
Okay.
That's our system cost.
I misunderstood that.
And what are you gonna, you have all the grading and stuff, you have something planned under as far as, you know, weeds and stuff, what do you have under there?
So the proposal that we did, we talked, when we met and talked about the scope of the project, we talked about some short grasses, some colorful flowers, that kind of thing. We put, one of our addendums in there, was, an adder to put rock underneath the panel lines, that you could just spray it down and not have to worry about that. But in the actual proposal itself is just a short type prairie grass with flowers.
Like you did rock.
What you're saying is the short grass, the whatever,
Yeah.
that's included in that.
That's
cost.
included in
The
that.
23.8 is if we wanna.
If you wanted to add, we put fabric down and rock down, and then maintenance wise, you just go there a couple times a year and just spray that rock area down
And
and
there's
not worry
one,
about it.
there's one gate opening.
Yes, one gate opening, yep. And we didn't specify the size of that. We figured we would work with them. I mean, we're covered on that, but we'd work with John or whoever, you know, what they needed for a gate and where they wanted it at and that kind of thing, so.
One thing the city's got to decide is if they're using the existing transformer location or if we're selecting a new transformer location. So them are some things that need to be decided, so we can factor some other things.
Yeah, there's no location, it'll be crossing the road, in the same fence as the, solar. But, so you have fewer inverters and more panels to them. So are we overclocking the inverters for a shorter lifespan?
You can oversize inverters up to 2.5 for the nameplate. So we could have went all the way up to, oh, I don't know.
Or we could have went-
2.5 megawatts DC.
Or we could have went
Still
down to
those-
4 inverters or maybe 3, 4
Yeah.
for sure,
Yeah.
yeah.
And so,
That's a good
so you know,
question.
No, you're not. So how the inverters work, and I was asking guys, listen, because in Laverne, I've got 330 kW going into a 200 kW inverter. What the inverter does, it just doesn't use that power, it just bleeds that power off and then you use it. So it'll sit out and crank out 200, but it's got 300 coming into it, but it just kind of bleeds that extra up, because the key is that, but what we do is we try to get that inverter up as soon as possible. So like these inverters will hit 200 kW like 9 o'clock in the morning. If you size it where it's 1-to-1, you know, you're gonna hit that peak at 11 or 12, and then it's not gonna be very long. We want that peak to go up and run like that, run down. You don't want it to rose and like that, because then you're not maximizing all the solar you have in the field. Yeah, so.
Trying to lengthen that bell curve out.
Yeah. Where modules have gotten the cost and all that, it's made sense to design like that. So you're over your yield of all the
So how
thousands.
many panels are on the inverter then? How many?
I think there's five, we got 2240 divided by 5, so it's almost just under 400 plus, I think, or so. Is that right?
450 roughly.
So you asked what we think is the best selling point. I think those two answered. I don't know. I mean, I think the system, it sells itself, right? I think for my selling point, I think it's community serving community, right? We're locally embedded into this community, so we have the best interest of this community in mind as we're standing here in front of you with our proposal. So I think that's our selling point.
But neither of you have ever done anything with solar before.
Oh,
Oh, yeah.
Oh, no,
Like that,
no, yeah.
okay.
Yeah, we've done,
Yeah, my company just does installs, like, as far as the racking, paneling, and just the whips to hook the panels together. But, Tim and I, well, we teamed up way back in 2014 for a few years, then we kind of did other things, and then we came back together here a few years ago, and so we've done quite a few installs for him the last few years, and sold some systems. I've sold some systems, and get the stuff from him, and then Don, you've done it for a long time in the last few years with us.
yeah, they brought me on board about 5 years ago. So we've been doing projects, us three stooges or however you want to, for about 5 years.
Solar's been a really hard market, so like, I've seen a lot of solar companies come and go, so the way I built my company is, I'm kind of the one guy that does everything. I go and get all the proposals and I have engineering on staff, who's been with me since 2008, so we've done a lot of projects, not just with my projects, but I bought into a company way back in 2000 called Integrated Power out in San Francisco, and that's how I kind of learned solar and get engineering. So a couple of guys that ran the company had some issues, so I kind of moved back to Iowa to build this industry here back in 2010. And then that's when I started on capital and got that tax credit and all that stuff passed. So there's been a lot of like embedment of energy and just like time into this industry. So the expertise, I think, is definitely there. And I've learned, so I've seen solar companies come and go. Guys build a company, they hire all these people, they ladders, trucks, all that. And then they go under, and I'm like, well, I don't want to build like that. So what I did is I just made kind of my own person. I would do everything, and I would sub out. So when I don't have a solar project for Randy, he's out building his stuff, and Don's out wiring his business. And then when I do have a solar project, I bring these guys in and just, kind of feather them in when I need them. So that's helped bring down cost. Because right now, I'm kind of teaming up with Brand Heating in Iowa City. So they have, 50 guys on staff. And so him and I are kind of butting heads on pricing, and because I'm always trying to bring stuff down, because Alliant, Mid-America's got cheap rates. And he's like, well, we price it this way. I'm like, well, you can't price it that way because it's, the investment is not there. So, I've been built where, and the way we're built is that it's very, I think, positive where we can keep our costs low, even though we were higher. And the reason why we were higher is just because we have more DC on that. That makes sense. We have more modules because we upped our module higher so we can run our inverters more and create more yield as well. Plus the module. I bet our module is probably a little more cost than the Xeon Shines, it's a Chinese module. I'm sure it is. But other than that, we're pretty comparable if you did apples to apples with the same system size. But the value you're getting out of us is, in my opinion, in this industry, as long as I have, there's a lot more value, especially with these two guys being
And
really
to
local.
answer your question, the last one, late last year, we did one for I-80 down there, I-80 truck stop, north of that new museum. That was 1,100 some panels, so.
Yeah, the big one behind their distribution. I've done all the solar for those guys. And then down in McKinley, North Carolina, Joplin, Missouri, stuck a $3 million system down in there.
1,100 panels there.
Yeah, just for their warehouse, I guess.
Their new warehouse, yeah.
Yeah.
Solar projects. Didn't keep me busy.
So given the higher DC side, does that mean we're actually going to get more than a megawatt?
Well, you'll get a megawatt from, the inverter only kicks out 200 kW. That's all it'll kick out.
Okay.
So we just run those longer. That's why we so when the sun comes up, you have more modules out there, you're getting more juice, right? So as we start rolling towards the sun, if we have more modules, that inverter is going to rise up faster, and you're going to produce more power over a longer period of time.
We just want that inverter to be running at 1 megawatt as many hours out of the day as we possibly can.
Agreed.
So that's why we add the additional panels to catch that early sunrise and that late sunset. If we brought that number down a little bit. Well, this number's gonna come down, then also your production number's gonna come down slightly. So it's like, we're just trying to maximize that peak. They run more efficient at 100% than what they run at 95%. So we're wanting to keep that thing right up there at 100%. So just in the utility world, you want those transformers humming, so that you're minimizing your line losses. So.
So the cell plan, or the cell plan, the app basically you're talking about,
Mhm.
is that a one-time purchase, one and done, or is there a yearly fee? for that?
First year's free, and then it's 5,000, I think it's $5,000 a year after that.
Okay. Then as far as like staff training, you guys go through all that with their electric department, show them how to do as much as we can comfortably.
Yep, we can do turnkey and take care of all the maintenance, or we can train on maintenance.
And what would if we had you do the maintenance,
I had a service agreement in there, so basically the maintenance is rolling through there once a
Okay.
year. And go through, just check all the connections, make sure everything's producing as it should, and just checking everything out. We do that annually. If there's a failure or something that comes up, then we'll go out there and check it more often, so.
And you said that's in there.
I think you had the first
There's a separate
3 years.
agreement
Yeah, that they asked for.
that we
Okay,
added with
gotcha.
the proposal.
I don't think
Did we get in the first 3 years?
What's that?
Dollar per KW.
dollar?
Yeah, it was pretty minimal. What was it, like 3,000?
Yeah, 0.001%, 1 cent or
Yeah.
something.
So,
And then you get 320 more panels, correct?
Correct.
Is that what I'm trying to read that?
correct.
Okay.
Yeah, 340.
Does that mean 320 more chances of issues or no?
Not really, not because of the technology now, if one panel, which panels don't go bad, I mean, very much, they're very, very, very good, but if one goes down, it doesn't take a whole string down or a whole inverter down, so.
The failure-
Inverters are the big points.
Yeah, the failure points are the inverters. So that's why we focus on minimizing the inverters, or the number of inverters. I should say.
I think the only panel that I had was a hailstorm that we had a couple years ago. I think it was like 3-inch hail, and it kind of hit in the same spot right on that module. And there were 168 modules in Alan Malley's farm, and we lost 2.
Yeah.
And he took a picture of the hail right by his foot, and it was like as big as this, it was
Yeah.
like 3 inches. So I was a little surprised that it took a hail beating like that, that big of a hailstorm. But you had a 30-degree pitch, so you're not really hitting it flat, you're hitting it like that. It's a lot of hail's bouncing off.
So,
But they've got video of these guys shooting bullets through these modules, and they're still producing out the current that they're doing. So it's a very robust technology that we're looking
And our contact for anything in the future is Rob, right?
Yeah, it can be that's fine, yeah. Myself. Yeah, myself or Randy, either one of us, yeah.
Depends on how mad you are, John.
They all got you on speed dial.
at. That's right.
Okay.
Yeah, and obviously, Tim, you can have Tim's contact, and we have all 3 of our contacts, but the reason we put the service agreement with Roth is because that's the failure point, or that's the things that need to be checked out. He's got the expertise to do that.
It's gonna be on the electrical side more than the
Exactly.
construction side, so yeah.
Makes sense.
If the structure falls over, I mean, that's
Yeah.
Randy's fault. but I
Yep.
mean-
I'm
We have
pretty
other
clear on
issues.
that.
I'm assuming once this gets up and rolling, you're monitoring it for some period of time just to make sure
Yep.
everything's running smoothly, we're up of efficiency like we need to be, anything need tweaked. Okay.
Yeah, I monitor all of our LED systems. They actually built a monitoring program, so if one goes down, I'll get an email right away or a call from one of their guys.
Sure.
And so, but I usually check them out once a week anyway, just to make sure they're up and running.
Okay.
What do you have planned for stormwater management?
During the project or after? Or what are you talking about?
Well, both.
So during the project, we have silt fence planned while we're doing the dirt work until we get the grass established, and we'll have to pull that out. We'll have that on the outside of the fenced area. And then after that, because it's all grass area, we don't have any retention or anything figured in.
So would you be working with whatever you have to do with the DNR, you would
Sure, yeah, yep, absolutely, yes.
Permits,
Yeah, we would get the stormwater permit, and everything. Yeah, during construction.
Is there anything you can think of that isn't included that we would have to take care of, or is it pretty much all there?
You want to
My
wash them
standpoint
maybe a couple times a year. Other than that, I think we pretty much cover.
Yeah, from my standpoint, I think everything's in there. I mean, obviously, we talked about the transformer, but you guys have a plan for that. Little things like the gate and that kind of thing, but that's pretty minor stuff, so.
You look at fencing matching the existing one that's there.
Yeah.
Good.
Yep.
Is there like an access road inside, or?
We didn't have anything planned. No, everything would just be grass area sod. So,
So your access would be from either end for each row.
Yeah.
Basically, you can drive around the perimeter of the site.
inside the fence, but yeah. We would probably, I guess, to your point, I would think we would have gravel access like to the transformer area.
Yeah.
And that kind of thing, yes. I mean,
Yeah,
but-
just an access point.
Yes, beyond
Doesn't
that,
matter if it's near or. not.
correct, yeah, but not like through the panels.
Yeah, no.
Did you have a diagram of what it's gonna look like? I don't remember if I saw one or not.
I didn't,
We did.
Did, but I
Did you have
don't-
like a diagram of what it's gonna look like with the panels in place and everything?
I don't have one readily available. I
We
don't-
had one, I didn't bring it with
Okay.
me.
And
We could probably
maybe I
email-
had,
we could
maybe you
email it
sent
to
it
you,
once
though.
too, I don't know.
So there is one thing that we can kind of do to increase production on the layout.
I think John might have.
And I sent this in the email to you guys. So north-south, we don't have a lot of room. We have more room east. Our subarrays are 13 feet apart. If we could move those up to like 20 feet apart, maybe make the rows longer, shift that a different way, then you'll increase your production. I don't know, maybe another 5 or 10%.
Mhm.
Because I was running some of these productions, my engineer's like, hey, you got your inner row space at 20 feet, I'm at 13, thanks for catching that. I go, well, then my production's gonna go down, isn't it, because of shading? He's like, yeah. He's like, well, I wonder if we could talk to them
And-
about.
A lot of this, because of the way this one orients with that hill, well, that hill will take care of a lot of it. But when you get to the northeast corner of it, where it's gonna be more flatter, that's where it's gonna affect it more. So our terrain will actually help with that on some of it, but on towards the more northeast or east end, northeast end.
So we're just trying to minimize the
Flatter.
amount of surface area with our design.
Mhm.
So, because you guys talked about expansion potentially to the west,
Yeah.
so.
Mhm.
Yes, correct.
Is there any issues with rodents and other varmints that eat stuff?
Not really. You know,
Well, I'm just saying, I mean,
No, yeah.
I lived in Arizona and
Squirrels.
we had little buggers that crawl in your engine and eat your spark plug wire.
Really?
Oh, yeah.
All wiring could be in conduit.
Yeah.
Well, the DC is exposed. That's why you have the perimeter fencing. So the DC wires is exposed, but it is, we have these clips that we use to clip them up tight against the rails so that they're not just dangling, but the DC wires are exposed. AC wires are not.
It was the same on the other.
So you have on this rack, you got C channels, so you just kind of lay that wire.
So we try to hide them as much as possible.
Yeah.
But, I mean, sure, you could get a bird building a nest or something like that, that could cause havoc, but I haven't seen it.
Is
Yeah, that's
wall cut
right.
your new panels? New panels, but that wall cut, the new ones you were talking about,
No, no.
they're not.
Solar is kind of like LED lighting. I don't know if you guys remember back to incandescent light bulbs, and then they came out.
What are those?
Yeah, then they came out with CFLs, right? And then they converted to LEDs. Well, you couldn't keep up with the changes LED was making for that first 5 years. Well, solar's the same way. They just continue to advance. So,
What is, I didn't think to ask this before any of this, but what kind of sound does this make? Like how loud is it? Or like it's just a humming noise? What is it? Do you hear it?
Yeah, you'll hear it. It's not like, I mean,
Inverters.
inverters will they have a high pitched noise because the DC comes in like, so it'll run sound like that. And we have them all kind of spaced together. So I mean, you'll hear them, you won't hear them from 400 yards or something, you'll hear them from 20, 30 feet.
So we're not gonna get complaints from housing.
No, they won't hear.
Where we have them
Like-
put right in the middle of the array, centered in there towards the east side, because, you know, you try to get the shortest AC line you can, because you got
I mean,
wire.
You could be standing next to them on the phone and it's not gonna bother you.
Okay.
You know,
The
yeah.
200s are,
We got,
yeah,
we have five, yeah, we
loud,
have a little
but
bit
they're not
louder,
crazy
yeah.
loud.
But yeah, we have 5 smaller inverters at my dad's. And, I mean, we were out there. the other
Yeah,
day.
those phones,
Yeah, but yeah,
pretty quiet. But the 200s will make some noise,
Yeah.
but they're not gonna be like, you wouldn't hear it from the fence.
Yeah.
If you might, maybe even 50 feet, you hear
Yeah.
the line, but
right.
yeah, you're not gonna have some huge, like,
That's a good question. though.
alarm
Yeah,
coming
it is.
out.
I think about that.
Storm
Yeah,
or
yeah.
something.
Yeah,
Yeah, I know, I had a project in Golden, Colorado, for, what's that? Natural grocers.
no, yeah.
So I had, back in the day, they used to have transformers in these inverters. Now everything's transformerless. So I had this huge, big inverter, like a refrigerator. It's a 50,000 watt inverter. Now they make them like this big, and set them right on the wall. And it was fairly loud inside there, the DC coming in. So I had to build a sound box around this thing. Yeah, but yeah. But then next year after that, they started going transformerless, which would have been a lot nicer.
Once again, I want to thank you guys for letting us come and talk with you, and I really appreciate it.
Thank you.
Thanks, guys. Thanks, John.
I'm afraid to ask. No, that was fine.
What are you doing a
I
research?
can tell you, stay right here.
What do you, oh, you're going back up?
I don't like being absent.
Every time.
Oh, really? It's good to do that. Get back to Florida. How hot was it? Hot?
No, 85.
Oh, that's perfect.
Yeah, it was. It was bad at all. Weather was great. My wife stayed again.
What do you take from that?
Keep driving back, right?
Oh.
Yeah.
To just give you an idea, for like rock or grass, let's say if you put grass underneath. you put grass.
Yeah.
Smart.
I'm waiting. Miss Brian, are you all ready? Okay. All right. So back to discussion of city business. So do we, y'all want time to think about it?
I do too.
Yeah.
I think that's a smart move.
Okay. So we will just make a motion to continue and
Table it
table it
the
till
next meeting.
Monday's
Till
meeting.
midnight. I'm good with that.
So motion.
Okay, so motion to table till next council meeting by Walker,
Second.
second by Johnston.
Welker,
Yes, ma'am.
Helm,
Yes.
Johnston,
Yes.
Cummins.
Yes.
Ashton.
Yes.
Okay, that concludes city business. Any reports from any department heads? John, do you have anything?
Not solar related. We've had an issue over at the motel in Liberty Bank that we're in the process of getting fixed. It's a commercial service that they were just out of power. I got some suspicions on why from last year, but we are scheduled to have an outage next week with both of those properties, and we've kind of put everything on our shoulders for this. This is a commercial service. We usually don't do anything past our stage warmer, but we've done everything up to this point, other than the digging that Roth is doing today. So other than that, I don't have anything else.
Okay. Do you have anything, Terry?
No.
Okay.
I'm looking at okay, regarding the properties that we're looking, that we've taken and so forth. By Spruce today. Couldn't get in, they got a lock on the front of the door. So I texted me the combination, I haven't heard anything back, so we might have to break into our own house. So just let you know.
Okay.
And also, as I spoke at the last meeting, and I want to get with Brian and maybe the mayor and see which properties we want to go after, or not go after, but to get rid of next.
The next round
I
of
mean,
RFPs.
there's 4 of them now that are vacant again. So, I mean, we're looking at 323 West A Street, 102 East 11th, 302 West 5th, and also, if I can get it back, 205 Spruce. So those 4 are all vacant, so I don't know if we want to do that, just do 4. Do we want to do all of them?
You know, if there are 12 left, I don't want to do 12.
No.
No.
I agree.
4 at a time would be.
That would be.
I agree.
And
Hope to be a whole
some of
weekend.
these are salvageable.
It'll be a long meeting.
That I don't think will be salvageable. And I will get a report to council, with what needs to be repaired, or to Brian, I should say. That's all I have.
Okay. Melissa, do you have anything? Nope. Okay, Brian? No, I don't have anything either. No, I don't have anything. All right, so if there's nothing further, motion to adjourn?
Motion. Second.
Motion by Welker, seconded by Johnston.
Helm,
Yes.
Johnston,
Yes.
Cummins,
Yes.
Posturing,
Yes.
Welker.
Yes.
All right. Motion, or, meeting adjourned. Motion